So let's continue the problems on probability. So the third question, why is tossing a coin considered to be fair way of deciding which team should get the ball at the beginning of a football game? Now basically, why is tossing a coin considered fair? Okay, because when we toss coin, either we get head or tail, isn't it? So the chance of getting head and the chances of getting tail is same, isn't it? So you have 50% chance of getting head and you got 50% chance of getting tail. So the chance of getting head is same as the chance of getting tail. So that is why we make use of this. Okay. So that's why tossing a coin is considered to be fair because there's a equal chance of getting head and tail. Now coming to the next question, which of the following cannot be the probability of an event? Now, the first option, 2 by 3, obviously the numerator is smaller compared to the denominator, which means this is a proper fraction. If this is a proper fraction, obviously the value will be less than 1. So we know that the probability of any event, the maximum value is 1 and the minimum value that you can have is 0. So all the values will be between 0 and 1. So this value is between 0 and 1. So this is a correct option. Okay. Coming to this 0.7, it is also less than 1. This is also correct. 15%, when we talk in terms of percentage, you will have it between 0% to 100%. So this is also correct. But if you observe this option B, which is in negative, that is not possible, isn't it? Because the minimum value is 0 itself. Minus 1.5 is less than 0. So therefore, this is not possible. So which of the following cannot be the probability of an event? Minus 1.5 cannot be the probability of an event. So let's get into the next one. If P of E is an event whose probability is 0.5, so if they have given P of E as 0.05, what is the probability of not E? That is complementary E. Okay. We very well know that P of E plus P of E bar, if we add these two things, we get the answer as 1. So P of E is given as 0.05 plus P of E bar is required, that is equal to 1. Therefore, P of E bar will become what? 1. We don't need 0.05. Send it the other side, it will become minus 0.05. Therefore, P of E bar will become 0.95, isn't it? 0.95. So that will be the answer. Let's get into the next question. The next question, a bag contains lemon flavored candies only. So there is a bag which has got candies whose flavor is only lemon. Malini takes out one candy without looking into the bag. What is the probability that she takes an orange flavored candy? Okay. So for the first question, let's say E is the event of getting an orange candy. Okay. Let's take it as P of E1. Okay. Let's take it as E1, where E1 is the event of taking orange flavored candy. Okay. So E1 is the event of taking orange flavored candy. Okay. Now in the bag, we have got only lemon candies. How do we get the orange candy? There is no chance, right? So the probability will be 0. Let's take the second question. Let's take it as P of E2, where E2 is the event, okay, of taking lemon flavored candy. So probability of E2 in the sense, P of E2 in the sense, probability of event that is taking lemon flavored candy. So whenever you take out any candies from that bag, it will be lemon flavored itself, because the entire bag is filled with only with lemon flavored candies. Therefore, it is 100%, right? Whenever you take, it will be a lemon flavored candy. If it is 100%, we write it as 1. So here we get to know that this is an impossible event and this is a sure event. So let's get into the next question. Once again, seventh one. It is given that in a group of 3 students, the probability of two students not having the same birthday is 0.992. What is the probability that these two students have the same birthday? So what they have given us, they have given us P of E bar, probability of students not having same birthday, that is 0.992. Okay. Now what we have to calculate is probability of the students having, two students having same birthday. So that is P of E. Again, the same relation, we know that P of E plus P of E bar, that is equal to 1, isn't it? So we have to calculate P of E. What is given for us is P of E bar, which is 0.992. So therefore, P of E will become 1 minus 0.992. Okay, therefore, which implies P of E, when you subtract it, we get 0.008, isn't it? So that will be the probability of these two students having the same birthday. Okay, now let's get into the next one. A bag contains 3 red balls and 5 black balls. Okay, there is a bag which has got, let's say this is the bag. Okay, in this bag we have got 3 red color balls. 1, 2. Let me draw it in red color itself. 3 red color balls. 1, 2, and 3. And there is 2 black color balls. Sorry, 5 black color balls. 1, 2, 3, 4, and 5. So we have got a bag like this. Now what we have to calculate in the first place is, what is the probability that the ball drawn is red? Okay. Now let E1 be the event of drawing red color ball. Drawing red color ball. Or picking, let's say event of picking red color ball. Now what we have to calculate is P of E1. Okay. Now, as we know, the formula is probability of an event is number of outcomes favorable to the event, whatever is favorable to us, divided by the total number of outcomes. Now, in the total number of outcomes, see how many balls are there totally? Totally 8 balls are there, isn't it? So let's say, for example, let's name this as 1, this as 2, this as 3, 4, 5, 6, 7, 8. So if you do an experiment of picking the balls, you might get, what are the results that you get? Let's say you're picking a ball, you get ball number 1. Second time you pick it, you get 5 or 6. These, I mean, different types of results that you get is what? Ball number 1, 2, 3, 4, 5, 6, 7, 8. Isn't it? These are the different types of results that you get on performing this experiment. So that is what we have written at the denominator. Okay. So the total number of results that you get. Okay. Now, the probability of choosing a red color ball. So how many red color balls are there? Only 3, right? So 3 out of 8. Okay. There is a, out of 8 balls, you might take 3 balls, isn't it? So the probability is like 3 by 5. Okay. So P of E1 is 3 by 5. So P of E2. E2 is the event of not taking red. Not taking red in the sense black, right? If it is not red, then it is black. So we know that there are 8 balls in which 5 are not red. So the probability will become 5 by 8. Or you can also do it like this. P of E1 is taking red. P of E1 bar will be not taking red, isn't it? If you add these two things, you will get the answer as 1, isn't it? So P of E1 is 3 by 8 plus P of E1 bar should be calculated equal to 1. Send this 3 by 8 to the other side. Okay, 1 minus 3 by 8. On taking LCM and solving it, you get 5 by 8. Okay, that is also there. Or directly you can do it. Okay, not red in the sense it is picking a black ball, right? So totally how many balls are there? 8 balls are there. Out of that, 5 balls are black. Therefore, it is 5 by 8. Let's get into the second question. The next question. A box contains 5 red marbles, 8 white marbles, and 4 green marbles. Okay, so totally how many marbles are there? 8, 5 plus 8, 13, 13 plus 4 is 17. 17 marbles are there. Okay. 1 marble is taken out of the box random. what is the probability that the marble taken out will be red? So P of E1, let's take it as P of E1, where E1 is taking a red ball. The total number of balls is 17. Out of this, how many are red? 5. So therefore, the chance will be 5 out of 17. Okay, this is the chance. Okay, the next one is taking a white marble. So let's take it as P of E2. What is the probability of taking a white color ball? Out of 17 balls, how many are white? 8 are white. So the chance is 8 out of 17. Okay. P of E3. Probability of not taking green. Not taking green is simply taking other two colors, isn't it? If you are not taking green, it will be other two colors. The other two colors are what? Red and white. How many are there? Red is 5 and white is 8. So totally you have 13 out of how much? 17. Therefore, the probability will be 13 by 17. Okay, let's get into the next one. A piggy bank contains 100 50 paise coins, 50 1 rupees coins, 20 2 rupees coins, and 10 5 rupees coins. So totally how many coins are there? 100 coins, 100 50 paise coins, 50 1 rupees coin, 20 2 rupees coin, and 10 5 rupees coin. So 150 plus 20 70, 180 coins are there. Totally we have got 180 coins. Okay. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paise coin? Okay. So E1 is the probability of taking a 50 paise coin. Now totally how many coins are there? 180 coins are there. Out of that, what is the probability that it will be a 50 paise coin? The chances are 100 out of 180. Okay. Now, the next one will not be a 5 rupees coin. So the next question is, will not be a 5 rupees coin. If it is not a 5 rupees coin, then it can be 50 paise coin, it can be 1 rupee coin, and it can be 2 rupees coin. So totally how many 50 paise coins we have got? 100. How many 1 rupee coin? 50. How many 2 rupees coin? 20. So totally we have got 170 coins, which are not 5 rupees coin, isn't it? So the chance is 170 out of 180. Okay. Next one. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. What is the probability that the fish taken out is a male fish? A very simple one. The total number of fish are what? 8 plus 5, 13. There are 5 male and 8 female, so total is 13. Out of this, what is the probability that the fish taken out is male? So the probability is 5 out of 13. Therefore, P of E will become 5 by 13. Okay. So let's get into the next question. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers. So the numbers are 1, 2, 3, 4, 5, 6, 7, 8. And these are equally likely outcomes. What is the probability that it will point at 8? Now, P of E1. Here, the total possible outcomes, that either you might get 1, 2, 3, 4, 5, or 6, or 7, or 8. So totally there are 8 possible outcomes. Out of that, what is required? You require only 8, right? So the probability of getting 8 will be 1 out of 8. Okay. So how many numbers are there? Totally 8 numbers are there. In that, there is only one number. There is only one place where it is numbered as 8. So there is only one chance out of 8. So that is P1, probability of E1. Coming to probability of E2, an odd number. Totally, the total number of outcomes or the total different numbers that you got is 8. Now, out of this, how many are odd numbers? 1, 3, 5, and 7. These are the odd numbers. So, totally, we have got 4 odd numbers. So, it will be 4 out of 8. Okay. Coming to the third one. a number greater than 2. So totally we have got 8 outcomes or 8 different numbers. In that, what is the chance of getting a number greater than 2? 1, 2, 3, 4, 5, 6, isn't it? So it is 6 out of 8. Now coming to the next one, P of E4, okay, a number less than 9, a number less than 9. So there are 8 numbers, and whenever you spin the wheel, definitely it will be a number less than 9, right? So it will be 8 out of 8, which is 1. Okay, the probability will be 1 here, or 8 by 8. So let's get into the next question. Coming to the die problem, a die is thrown once. Find the probability of getting a prime number. So when a die is thrown, what are the outcomes? 1, 2, 3, 4, 5, or 6. These are the outcomes. So our total number of outcomes is 6. Okay. Coming to the first question, the total number of outcomes is 6. In that, what is required? A prime number. So 2 is a prime number, 3 is a prime number, 5 is a prime number. So totally we have got 3 prime numbers. Okay. So 3 prime numbers. So that is P of E1. Coming to the second one, a number lying between 2 and 6. Between 2 and 6, how many numbers are there? 3, 4, and 5. So there are 3 numbers out of 6. So that will be P of E2. These are very, very simple questions. An odd number, again, P of E3, that will also be 3 out of 6. Isn't it? The odd numbers are what? 1, 3, and 5. So there are 3 odd numbers out of 6. So 3 out of 6. Coming to the next one. This is a problem based on cards. One card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of red color. Okay. Now let's say this is P of E1. This is the first question. Now totally how many cards we have got? 52 cards. Isn't it? There are 52 outcomes. You might get 2, 3, 4, 5, 6, 7, 8, 9, 10, king, queen, jack, or ace of hearts, or of diamonds, of spades, or clubs, anything. So that totally there are 52 cards. All these 52 are different, right? So we can say there are 52 outcomes. Or in simple words, we have got 52 cards. Out of this, how many red color king card we have got? King of red, how many king of red do we have? We have 2, isn't it? One from hearts, we have got a king, which is red in color. And from diamonds also, we have got a king, which is red in color. So it is 2 out of 52. Coming to the next question. A face card. As I told you, king, queen, and jack are known as the face card. So in hearts, you have 3. In diamond, you have 3 face cards. In spades, we have 3 face cards. And in clubs, we have got 3 face cards. So totally how many face cards? 3 from this, 3 from this, 3 from this, 3 from this. Totally it will be 12, isn't it? So there are 12 face cards out of how much? Out of 52, isn't it? Coming to the third one, a red face card. Now how many red face card you have? Only in heart, only heart and diamond are red in color, isn't it? So in hearts, you got 3 face cards, and in diamond, you got 3 face cards, isn't it? So totally it is 6 out of 52. So P of E3, probability of an even 3 is 6 out of 52. Coming to the next one, fourth question, jack of hearts. So in hearts, how many jack do we have? Only 1, isn't it? Out of 52. Out of 52 cards, there is only 1 jack of hearts. So coming to the fifth question. Okay. A spade. How many spades do we have? We have 13 spades, isn't it? Out of 52. Coming to the next one, the queen of diamonds. In diamonds, how many queens do we have? We have only 1 out of 52 cards. So these are the answers. Let's get into the next one. 5 cards. Okay, now we have got only 5 cards. Which are those 5 cards? The 5 cards are 10, jack, then queen, then king, and then ace. These are the 5 different cards we have got. And these are well shuffled. 1 card is then picked at a random. Okay. The first question, what is the probability that the card is queen? Okay, that is P of E1. What is the probability that the card is queen? Now totally how many cards are there? We have got 5 cards. Out of that, how many queen cards we have got? We have got only one card, which is queen, isn't it? Therefore, it is 1 out of 5. Okay. Coming to the second question. If the queen is drawn and put aside, so we are taking out this queen. Okay. We don't need this queen. Let's take it out and let's put it somewhere. We don't need it. We'll put it. We have thrown it that side. Okay. Now, how many cards do we have? We have got only 4 cards, isn't it? Now, in that, what is the probability that the second card picked up is an ace? First card, we took it as queen and we throwed it. Forget it. Now, we have got only 4 cards. In this 4 cards, what is the probability that of getting an ace? It is 1. There is only one ace out of 4 cards. That is E2. In this, there is one more question. Let's take it as E3, probability of E3. What is the probability that it will be a queen? Out of 4 cards, is there any queen? No, we have thrown it outside. So it is 0 by 4. Therefore, it will become 0. Coming to the next one. 12 defective pens are accidentally mixed with 132 good ones. So there are 132 pens which are good and 12 pens which are defective. Now they are mixed. So total number of pens is how much? 144. It is not possible to just look at the pen and tell whether it is defective or it is good. So one pen is taken out at random from the slot. Determine the probability that the pen taken out is a good one. So you have to find the probability that the pen taken out is a good one. Now, how many pens do we have? We have 144 pens. In that, how many are good? 132 are good, isn't it? So the probability will become 132 out of 144. Out of 144, 132 will be good. Okay. A lot of 20 bulbs contain 4 defective. So in 20 bulbs, there are 4 defective. One bulb is drawn at random from the lot. What is the probability that the bulb is defective? Okay. So P of E1, the probability of being defective, that totally there are 20 bulbs in which how many are defective? 4. So it will be 4 by 20. Coming to the next one, not defective and it is not replaced. Suppose the bulb drawn is not defective and is not replaced. Okay. So the probability of taking a bulb which is not defective. How many are not defective? 4 are defective, which means the others are not defective. So 16 out of 20. Okay. Next, what is the probability that this bulb is not defective? Okay, here, the second part actually, suppose the bulb drawn in 1. Okay, this one corresponds to this one here. Okay. Suppose the bulb drawn in the first one is not defective. That is in the first question. We took a bulb and what is the probability of not defective was? What is the probability of defective was? 4 by 20. Now, what they're saying is, suppose you are drawing a bulb, okay, and it is not defective. Okay. You have taken a bulb which is not defective. Okay, forget it. Now, what is the probability that this bulb is not defective? Okay, first what you did was, there were 20 bulbs. In that you picked one which was not defective. Okay, this is not defective. Now you have taken one. Again, from the rest, that is out of 20, you have taken one. What is the rest? 19. From this, suppose you are taking one bulb, what is the probability that it will be not defective? That is the question. Okay, I hope the question is understood. Let me repeat it again. You have 20 bulbs. In that you are choosing one. Okay, you took randomly, you took one and you found that this bulb is not defective. Okay, this bulb is good. Okay, now how many are left out? We have 19 bulbs that are left out. In this 19 bulbs, now you are taking one bulb. Okay, now the question is, this bulb, what is the chance of this bulb not being defective? Okay, that is the question. So the total number of bulbs that you got is only 19, isn't it? From this 19 bulbs, you are removing a one bulb and you are asking the chance of not being defective. Now totally how many were good? You had 16 bulbs which were good. In that you removed one, isn't it? This one which we have written here. We had 16 good bulbs. In that, we have taken one bulb and we have kept it here. So how much is left out? 15 is left out, right? So 15 bulbs are good. They are not defective. So it will be 15 out of 19. I hope this is understood. So let's get into the next one. A box contains 90 discs, which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number, a perfect square, a number divisible by 5. So the first question, P of E1. Now totally how many discs are there? 90 discs are there and all are numbered from 1 to 90, isn't it? So we have got 90 discs which are numbered from 1 to 90. So the number of discs is 90. In this 90 discs, what is the probability that will be a 2-digit number? Now, out of 90 discs, only 9 discs, that is the discs which are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9. Only these 9 discs are single digit. Rest are double digit, isn't it? Therefore, in this 90, 9 are single digit, which means the rest are double digits. So out of 90, 81 discs are double digits. Therefore, the probability will become 81 by 90. Okay. Let's get into the second one, P of E2. What is the probability of getting a perfect square? Now, the discs are numbered from 1 to 90. In 1 to 90, the numbers which are perfect square. 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, then 16, 25, 36, 49, then 64 and 81. The next one will be 100, but we have discs which are numbered up to 90. So you cannot take this 100. So these are the discs that are perfect square. Okay. So totally we have got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have got 9 discs out of 90 which have perfect square. Coming to the next one, P of E3, probability of event 3, a number divisible by 5. So the discs which have the number that are divisible by 5. So let's say a disc with number 5, it is divisible by 5. Disc with number 10, it is divisible by 5. Basically 5, 10, 15, 20, 25, then 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, and 90. So there are discs which I have drawn here. All these discs have numbers which are divisible by 5, isn't it? All the multiples of 5. So totally how many are there? Here we have got 5. Here we have got 5, and here we have got 5, and here we have got 3. So totally it is 15 plus 3, 18 discs out of 90. So out of 90 discs, 18 discs have numbers which are divisible by 5. Therefore, the probability will be 18 out of 90. Let's get into the next one. A child has a die whose 6 faces show the letters as given below. So we have got a special die which has got the faces as shown. That is, one face is A, the other one is B, other one is C, then D, then E, then one more A. Okay. Now, if the die is thrown once, what is the probability of getting A? Now, there are 6 faces, isn't it? Out of 6, the possibility of getting A is 2, because there are 2 A's, one here and one here. So 2 out of 6. That will be probability of getting A. Next, probability of getting D. There is only one D out of 6, isn't it? So therefore, it will be 1 out of 6. Coming to the 20th one, you got a mat like this, let's say a rectangular region, and inside we have got a circular region. Now, suppose you are dropping a die on this. What is the probability that it will land inside the circle itself? That is the question. Now, we have to calculate P of E. Now, this is not a question which is important for the exam. Okay. Now, here, the probability of dropping a die inside the circle depends on the area of the circle, isn't it? If the area of the circle is more, if it is very, very big, so the chance is more. isn't it? If the circle is very, very small, the chance is less. Now, if you drop a die on this mat, it can fall anywhere, right? Anywhere on this. So the possibility is, that is the total possibility will be equal to the area of the rectangle. Whatever is the area, it can fall here, 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 anywhere. So what is the area of the rectangle? Length into breadth. So here length is 3 and breadth is 2. 3 into 2 is 6. Okay, that's the area. In that area, what is the area of this circle? The area of the circle is pi r square, and here the diameter is given as 1, isn't it? Therefore, the radius will become 1 by 2. So here we can say that if I take pi as 22 by 7, okay, so diameter is 1, so radius will become 1 by 2. So 1 by 2 into 1 by 2. 2 ones are 2 11s are. So it will become 11 by 14. Okay, so this will be the area of the circle. Now if I substitute here, it will become 11 by 14 divided by 6. You can transpose this. I mean to say, you can reciprocal it. It will become 1 by 6. So it will become 11 out of 96. Okay, so that is the possibility. Now here we have calculating the probability in terms of area. Okay, this is not an important question, so we can also skip this. Let's get into the next one. The next question, we have got a lot consists of 144 ball pens, of which 20 are defective. So we have got totally 144 ball pens, of which 20 are defective and others are good. So Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she'll buy it? Okay, the probability that she'll buy it. So P of E1, let's take it as P of E1. Now totally we have got 144 pens, out of which 20 are defective, which means 124 pens are good. So if she wants to buy it, then the probability will become 124 out of 144. She will not buy it if the pens are defective, isn't it? So it is 20 out of 144. So let's get into the next question. So we have to complete the following table. The event tree is given here as sum on 2 dice. So we are throwing 2 dice, okay, and whatever the answer that we get, okay, we are gonna calculate probability on that. For example, the sum on 2 dice, in the first column we have got 2. That is, if you are throwing a die, and what is the probability that and are adding the numbers you get 2. For example, let's say you are throwing a die which is 1 and you get 1, and let's say you throw another die, you get 1, and if you add these two, you get 2. Okay, isn't it? So totally how many possibilities are there? 36 possibilities. Okay, 1 plus 1 is 2. So this is the only possible chance, isn't it? For this, let me write the table itself. When you throw 2 dice, these are the possibilities, isn't it? 1, 1, 1, 2, 1, 3, so on up to 1, 6, which we have discussed in the previous video. Similarly, 2, 1, 2, 2, so on up to 2, 6. So similarly, 3, 1 up to 3, 6, 4, 1 up to 4, 6, 5, 1 up to 5, 6, 6, 1 up to 6, 6. Isn't it? These are the different possibilities when you throw 2 dice. Okay. Now, the first one is, they've already given the answer, but we'll calculate it. Sum on 2 dice is 2. That is, the results that you get, if you add them, you should get 2. What is the chance of getting 2? For example, here we have got 1 and 1. If you add it, you get 2. This is the only chance, isn't it? That the sum is 2. So out of 36 possibilities, there is only one chance. That's why in the table they have written it as 1 out of 36. Similarly, let's verify this 8th one. Okay, that is, sum on 2 dice should be 8. That is, if you add the numbers, you should get 8. How many such chances are there? So if you observe 2, 6, this is a possible thing, isn't it? Because if you add these numbers, 2 plus 6, you get 8. So this is one chance. Okay, Next one is 3 comma 5. You will have 3 comma 5, which is also possible. Then here 5 comma 3 is possible, and here 4 comma 4 is possible, isn't it? And here 6 comma 2 is possible. So therefore we have got 1 2 3 4 5 5 times out of 36. So as you can see here also, they have mentioned it as 5 out of 36. Similarly, let's check the last one, which they have given it as 1 out of 36. That is, the sum on the dice should be 12. That is, if you add the numbers, you should get 12. Okay. Now that is possible only here, isn't it? 6 comma 6. If you add it 6 comma 6, you get 12. This is the only chance out of 36, isn't it? This is the only case out of 36. So they have written it as 1 by 36. Similarly, we have to fill up the table. Now let me do the second one. That is, the sum on the dice should be 3. If you add the numbers, you should get 3. That is possible. One case is 1 comma 2. If you add 1 and 2, you get 3. Or let's say 2 comma 1, you get 3. Is there any other possibility? No, isn't it? So you don't have any other possibility. There are only 2 cases out of 36. So we write it here as 2 out of 36. Now what is the chance of getting 4? Okay, now let's see the cases. 1 comma 3 is a case where you get the answer as 4. If you add 1 and 3, you get 4. Or 3 comma 1 is also a possible thing. Or 2 comma 2 is a possible thing, isn't it? Any other chance? Any other cases? No, isn't it? So there are only 3 cases out of 36. So we can fill this as 3 out of 36. Now what is the chance of getting 5? Now 1 comma 4 is a case. The reverse, 4 comma 1 is also a case. 2 comma 3 and 3 comma 2 is a case. Apart from this, do we get 5 in any other cases when you add it? No, isn't it? There is no other case. So therefore, we have got only 4 cases out of 36. Now coming to 6. Now let's see the cases. 1 comma 5 is a possible thing. If 1 comma 5 is possible, that is, if you add, you get 6. 5 comma 1 is also possible. Okay. The next thing is 2 comma 4. If 2 comma 4 is possible, then 4 comma 2 is also possible. Then 3 comma 3. If you add 3 comma 3, you get 6. Then 4 comma 2 is already done. 5 comma 1 is also done. So therefore, how many cases we have got? 1 2 3 4 5. So it is 5 out of 36. So similarly, you can try out the other things and you can fill up the table. Let's get into the next question. A game consists of tossing 1 rupee coin 3 times. So as I told you, tossing a 1 rupee coin 3 times or 3 coins at a time is the same thing. Okay. Now a game consists of tossing 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result. That is 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. Okay. Now let's write all the outcomes when you toss a 3 coin. Head, 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 3 coins or 1 coin 3 times. Or head, head, tail, head, tail, tail, head, tail, head. These are the other 4. Tail, 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 head, tail, tail, head, head. Then tail, head. Once again, tail, tail, head. Yeah. So these are the 4 things, and 4 plus 4 is 8. Totally, we have got 8 different outcomes. Okay. Now he's gonna win only if he gets all the 3 same. That is head, 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 or tail, tail, tail. In rest of the cases, he's gonna fail. So out of 8 different outcomes, he's gonna fail 6 times, isn't it? There are 6 possible cases where he's gonna fail. Okay. So 6 out of 8. So the probability will become 6 out of 8. Out of 8 different outcomes, he's gonna win only 2 times. That is head, 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 or tail, tail, tail. Rest of the things is gonna lose the game. So it is 6 out of 8. Let's get into the next one. A die is thrown twice what is the probability that 5 will not come up either time? Okay. Now a die is thrown twice or two dice at a time. Both are one and the same. Okay. What is the probability that 5 will not come up either time? Okay. Now we've already discussed the outcomes. Let's rewrite it again. What are the outcomes when you throw two dice? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, 2, 1, 2, 2, so on up to 2, 6. Then 3, 1 up to 3, 6. Okay. Just to save time, I'm not filling everything. 4, 6, 5, 1 to 5, 6, and 6, 1 to 6, 6. So when you throw two dice, these are the all possible outcomes. Now the question is 5 will not come up either time. That is, in both the dice it will not come. Okay, in the first dice also it will not come. In the second, that is in the first throw also it will not come. In the second throw also it will not come. So instead of calculating how many times it doesn't come, let's calculate how many times it comes. Okay, now here 1, 5, it is coming second time. Okay, so here it is coming 1, 5 is a case. Then the reverse 5, 1, 2, 5, 5, 2, then 3, 5, 5, 3, 4, 5, 5, 4, then 5, 5, you cannot write again 5, 5, then 6, 5, and 5, 6. Isn't it? 5, 6 and 6, 5. So totally if you observe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So totally there are 11 cases where the 5 will come either the first time or the second time. Okay. So 11 out of 36. Okay. But the question is, what is the probability that will not come up either time? It is not going to come at all. So 11 times it is going to come out of 36. Therefore, very easily out of 36, 25 times. If 11 times it comes, the rest is what? It doesn't come, right? So 25 times it is not going to come either time. So the probability will become 25 out of 36. The next question, 5 will come up at least once. Remember, when we use the word at least once, in the sense it can also come more than once. Okay. The minimum is once. The maximum is any number of times. So here 1, 5, it has come once. Okay. 2, 5, it has come once. 3, 5, 4, 5. Then if you observe 5, 1, 5, 2, 5, 3, 5, 4, okay, 5, 5, 5, 6, and 6, 5. Okay. Again, the same thing 11 times, isn't it? So the probability that the 5 will come up at least once is 11 out of 36. Remember, when we use the word at least, it means minimum is one time, maximum is any number of time. Okay. So the first one answer is 25 out of 36 and the second one is 11 out of 36. How did we calculate the first one? What we did was the probability of getting 5. That's what we calculated, which was 11 out of 36. Okay. But what we need is 5 will not come up either time. So it is like complementary event. Simply you can subtract it from 1 also. Directly you will get it. Or out of 36, 11 time it comes in the sense remaining 25 it doesn't come. So it will be 35 out of 26. This is also possible. Coming to the next question. If two coins are tossed simultaneously, there are three possible outcomes. 2 heads, 2 tails, or one of each. Therefore, each of these outcomes, the probability is 1 by 3. Okay. Now, the question is, which of the following arguments are correct and which are not correct? Give reasons. Now, when we toss two coins, what are the possibilities? We get 2 heads, okay, and either we get head and head, okay, tail and tail, or head in the first coin, tail in the second coin, tail in the first coin, head in the second coin. Here, there are 4 different outcomes, isn't it? The question is, What is the probability of getting any one thing? Let's say you want both heads. What is the probability? It is 1 out of 4. Or both tail. Again, it is also 1 out of 4. Head or a tail, it is 1 out of 4. Tail or head, that is also 1 out of 4. So in all the cases, the probability of getting any one thing is 1 out of 4. But in the question, they've mentioned it as 1 out of 3, which is wrong. So therefore, this is an incorrect statement. Now coming to the next one. If a die is thrown, there are two possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2. And it is actually a correct statement because when you throw a die, these are the possible outcomes. 1, 2, 3, 4, 5, 6. Now, there are totally 6 outcomes. Out of this, how many odd numbers are there? 1, 2, 3. So 3 out of 6. And if you simplify it, it is actually 1 by 2. So therefore, this is also a correct statement. So with this, we have completed the exercise problems on probability. I hope you guys have understood. Thank you, students.